Okay, we're on. All right. Group meeting.
Individual preparation signage.
True. The first part of these.
Are they timed?
I don't think so.
Okay.
No.
All right. So you need to say your name for the
Yep.
video so that he knows who's on it.
All right. Taylor Dalrymple.
My name's Will Boozenbark.
Got him.
Okay. Chill. Okay. First question. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. O, 0.45, A, 0.40, B, 0.11, AB, 0.04. The blood types and the proportions given in the table above define a probability distribution. True?
I think true, yeah. True.
What is the probability that a randomly selected person in the United States is O blood? 0.45.
Yeah.
We're laughing now, but I'm sure it'll get harder.
Yeah.
You already took it. Does it get harder? A little bit.
Yeah.
What is the probability that a randomly selected person will not have O blood? So 0.55 because it's 0.45 minus
Difference.
200. Yeah.
Yep.
Or 100 minus
0.45. Yep. 0.55. Save. I'm not used to saving it after everyone.
Carol. Okay.
No, that's okay.
Go ahead and read that one.
All right. Caroline Wills and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to the specimen derived from a bladder cancer patient. Tangle one of the dogs demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? So there's how many total?
7 bowls.
7 bowls total. One of them is a bladder cancer patient, and the other 6 are not.
Okay, so what is the probability that they'll guess correctly? The total would be 1 in 7.
Right, yeah.
And then would you multiply or divide that by 1 in 6? Or 1 in 7? They could guess at random and get it 1 in 7 times.
Yeah. So would it just be the percentage that is?
Yeah, and we need to answer in decimal places.
So it's just the 1.
1428.
Yeah. Does it say
Or 142?
round? Yeah, round to 3.
142.
Right. Because you just did 1 divided by 7. Right. That's all you did there. Yeah.
142.
143.
Yeah.
Or do we do 143?
Oh.
Round it up to
Round.
the 143.
Okay. Yeah, sure. We got 2 tries. Don't worry about it.
Oops, so yeah, right.
Technically, we got 6 tries because there's 3 of us in our group. So
That's true.
we really bombed it twice. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate?
This provides strong evidence that dogs can detect bladder cancer, and there's little evidence. So
Well,
isn't it, if it's
in 54 tries, it'd be 22 out of 54 plus 1 out of 7 or something like that, which is pretty good. It's a lot better odds than the Columbus guy
Right.
guessing the 4 beans or whatever.
Mm-hmm.
I'd say strong evidence.
Mm-hmm. Wasn't there like a certain level at which it becomes strong evidence? I couldn't remember. Randomness. I couldn't remember what it was. Evidence. Oh man, I can't remember where it was that I was reading about. But I think you're like kind of what you were saying though, is that compared to like the Christopher Columbus example, pulling out those 4 beans, that 22 out of 54 times, especially something like that, is pretty strong evidence.
50% on that. That seems like.
Yeah, I think you're right on that one.
Okay, we'll just go with it.
Yeah, let's try it.
We can. Okay.
Alrighty.
Take Math 108. The beginning of this is a lot like Math 108.
All right. Yeah. All right.
So M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table: brown 0.13, yellow 0.14, red 0.13, blue 0.24, orange 0.20, and green. Okay.
Whatever's left over.
Okay. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? 1 in 13? No.
0.13, right?
0.13, yeah.
Yeah.
Oh, because you want it in decimals? Yeah.
Yep. So what's the probability of selecting a green-colored candy? 0.13 plus 0.4 plus 0.13 plus 0.24.
You like math.
Plus 0.20. So it would be 0.16.
Okay, because deducted.
Yeah, so brown, yellow, red, blue, and orange together equal 0.84.
Totally. Yeah.
0.16.
And the probability of it not being green is 0.84.
Yep. 0.84.
The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from CAPEX. The following summary statistics were calculated. Okay, half of the observations are less than or equal to what number?
Less than or equal to would be medium-sized. It'd be the median? No.
Yeah.
Or the mean?
Mean. Because the mean's the average, I thought.
Right.
So the median would be that middle number?
Well, yeah, it'd be the dead center number. Half of the observations are less than or equal to. Ooh.
So we should find the median now.
Yeah.
Denoting or relating to a value or quantity lying at the midpoint of frequency. Okay, how do you...
Oh man. Yeah, the median. We're not going to be able to do it without the full set of data. I'm just trying to remember from what we read if it was, because the mean is the average of all the numbers, right? I think it's probably the median, because how you get the median is you take all the numbers in order, and then whatever the center number is, or the 2 center numbers divided by 2, like you add them together, divided by 2, that's the direct center. So it's like that half is going to be lower.
Yeah.
So I think it's the median,
Okay.
24. I can't remember though. I hope that's.
Well, we can do it. We have time.
Should we try it? See? Is that 24?
I have no real paper. 4.3 is the first one. 4.3. Third, 5. 14. 22, 24, 24.2, 24, 24.3. What comes after that? 27 and 35. Oh, I missed 18.6. 4.3. 27 and 35. How many numbers do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 1, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1. 18.6 with it?
Yeah.
So it's
well, what these are though, like this is just saying from this website, the summary of the statistics on their website. So the average is 24.3 from another set of data that we don't have. So it's not this set of data here. This is just giving us from the data set that they took that mean was 24.3. The standard deviation was 4.
The median was 24.
Right.
Wow, I didn't even read what it said.
Yeah.
I'm sorry.
No, that's okay.
I'm sorry.
No big deal at all. But yeah, so I think it's 24 because it's like that dead center number, and then whatever's to the left of that is equal to or less than that number.
Okay. So 25% would be the fourth quartile, or quarter 3.
So let's see. Based on the information on the table above, the top 25% of students scored above what number? Quartile 3. So it'd be So yeah, because it's saying not the 25th percentile, but the top 25, which would be 75 to 100, right? So I think you're at the quartile 3. 27. All right. Which of the following statements is not one of the 3 rules of probability? The probability that an outcome will occur is 1 minus the probability that it will occur. A probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then it's negative. And the sum of the probabilities in any probability is 1. So this is down. Right here at the bottom. Okay. Probability is a number between 0 and 1. The probability of those outcomes will occur is 1. And the probability that an outcome will not occur is 1 minus the probability.
I think it would be the third one, right?
If the probability is high. Yeah, that's exactly what I was thinking. It would be positive.
I'll submit it, and then we'll see what happens.
Okay.
Yes. 2 out of 2, 1 out of 1, 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 1 out of 1. Good. Nailed it.
That's what, brother.
Well, it was a great group meeting. Thank you all for coming today. Got a diaper to change.
Baby to make happy.
He's happy. He just had to squeeze
Yeah,
something
he's
out.
He's cute, man.
Yeah, you like him.
All right, so then I'll come here and close this down.